Hi, Nelson Pavao, Regional Sales Manager at DuroVac.
Hi, I'm Pritika Saini. I'm the Engineering Manager at DuroVac. The type of material being collected plays a major role in how a vacuum system is designed. Fine dust doesn't move the same way as metal scrap, abrasive powders, or any dense material. Material properties like particle size, bulk density, moisture content, abrasiveness all influence how the material behaves. From airflow to filtration to filter separator design and the discharge method. Understanding the material early helps prevent issues like clogging, premature wear, poor pickup performance, or a system that isn't suitable for the application. Combustibility cannot be treated as a secondary detail. Fine dust and powders can create serious hazards when they become airborne, especially if there is a potential ignition source like heat, spark, static electricity. And in many cases, a material can seem manageable in bulk, can behave very differently during collection. When handling combustible dust, our systems are designed to comply with NFPA standards. In some facilities, the environment may also be classified as hazardous location. For example, areas may fall under Class 2, Div 1 or Class 2, Div 2 classifications for combustible dust. These classifications affect what safety measures needs to be considered. Distance has a direct impact on the vacuum system performance. The farther material needs to move from the pickup point to the vacuum system, the more the system needs to account for friction losses, pressure losses, airflow stability, and conveying efficiency. For shorter distances, flexible hose may be sufficient. As the distance increases, the hose alone can cause resistance, more wear points, and less consistent airflow. In those cases, we recommend a rigid piping network. Distance also influences how the system is laid out, how many pickup points can be supported, and the level of vacuum required to keep the material moving.
The number of operators that will be using the system at any one time, important part of the system design. When we were sizing a system, the number of operators will determine the type of horsepower that's going to be required, the type of airflow that we're going to need at each nozzle, and ideally we want to size it so that the pickup is identical or as close to identical for every single pickup point throughout a fully installed system. Maintaining the correct amount of airflow and CFM through each hose will ensure that you can bring material back to the filter separator and to the discharge. Oversizing it, it'll overheat the system, put extra wear and put extra strain on it, ultimately costs more money to run. Portable versus central. Ultimately, it's always going to come down to your specific facility needs. The biggest advantage to a portable is exactly what it is. It is a portable. Disconnect it, move it to an area of need for a larger spill recovery. What makes the most sense? Do you have the floor space? Do you have the footprint? Is it a continuous operation? If it is, generally we tend to lean towards central systems that are going to have a continuous discharge. Our portable systems can be used as central systems, and in many cases they do double. We like to call it a hybrid system because, again, it is portable. It can be moved to specific locations, but it can also be connected directly into a tubing network. All our systems are designed for either indoor or outdoor. It's going to come down to footprint. Sometimes there is no space. Maybe they want to keep the sound down, so it makes more sense to have the unit outside. In a lot of remote destinations, there is no electrical power. With our diesel and propane options, we can service areas where there is no available electrical grid. Everything from NEMA 4 enclosures for our electrical, motors are all designed to withstand the elements. So whether you want to park your unit outside or inside, it'll run famously tough as always.